Welcome back to my YouTube channel. And in this particular video, we're going to be talking about the linear equations. We're going to be talking about linear equations. So now, linear equations, how do we identify linear equations? Linear equations are identified when we have the form of dy dx plus p of x, p a function of x multiplied by y equals to q of x. And we know that when we have a linear equation, we multiply everything by the integration factor of e raised power the integration of p dx, and after we have done that, we do y is equals to 1 over integrating factor integrated by integration of q of x multiplied by the integrating factor dx, which is this particular form. But what I came here to do today is I came to explain why did we have this formula and how do we get our integration factor. How did our integrating factor become e raised power the integration of p dx? So now that is what I'm going to explain. So first of all, we said a linear equation is identified by this particular factor here. So if we are going to be having dy dx plus p, which is a function of x multiplied by y, is equals to q of x, something like this. And we want to know we need an integrated integration factor for us to be able to solve this question here. We can just assume any number at any digit, let's say alpha or beta, something like that. So let me say I multiply everything by um, beta. I multiply everything by beta, multiplied by beta, and I multiplied by beta, stuff like this. So if I multiply everything by beta, then I am supposed to be able to solve this particular equation. But when I'm having something like this, for me to be able to simplify this, I want this to be a differentiable factor, that is something that we can have this as the differentiation of y, differentiation with respect to x of beta and y, of beta and y. This is what I want this entire place to become right here. So now, and we know that if we are doing product 2, this is going to be equals to beta multiplied by the y dx plus our y multiplied by the differentiation of beta dx, yeah, something like this. So now we want everything here to be of this particular form, and we have seen that b dy dx is already here. So now this is equals to this right here. So therefore we must have this to be equal to this right here, since this is equals to this. So therefore we focus on the both of them here. We have our beta p of x y is equal to y times differentiation of beta dx. So now let's look at this right here. So now we can see that this here can be solved using the separation of variables. So we can just bring beta to one side and the functions of y to the other side. And we see that here, y here and y here. So we can divide both sides by y first, y cancel y, and y cancel y here. So what we are left with is our beta times p, or our p of x rather, is equals to the beta the x. We can use separation of variable here. Our x comes here, so we have p of x dx is equal to differential of beta over beta right here. So now we have our p of x dx. If we put integration in both sides, yeah, we are going to just leave this as integration of p of x dx, because we don't know the particular equation that is there. And here we are going to be having ln beta. But now beta is our integrating factor here, which is I of f. So we can just add e to both sides to cancel out the ln. So therefore we are going to be having our beta is equals to e raised power the integration of p of x dx. So now this here is how we got our integrating factor to be e raised power the integration of p dx, which is our p of x dx right here. So now that we have gotten our integrating factor to be this, how do we solve this particular equation? So first of all, as I said earlier here, we multiply everything here by our integrating factor in order to be able to solve it. So what we do is multiply everything by e raised power the integration of p dx times dy dx, and then we have plus our beta here, that is e raised power the integration of p dx, and we have our p of x here, and we also have our y. So now that is this for this. So now if we look at this very well, we would notice that everything that is here can be counted as the integration. Everything that is here can be simplified. We have done it already in a way that both of them can be simplified into this particular form here, which we are going to be having this here is can be simplified into this particular form. So now let us look at that. So everything here can be simplified into d the x of e raised power the integration of p dx multiplied by y here. So now this is the particular form in which you can get this. And if we look at something like this very well, this is already differentiated with respect to y. If we look at something like this very well, if we try to like integrate again, we are going to get a differentiable factor for this, something like that. But everything here is going to give us something like this because that is what we intended it to be from here, to give us this. So let us continue. We have this now would be equal to our beta times q of x, which is our integrating factor, e raised power the integration of p dx times q of x, or just q, either way. So now that we have both sides, we just add our integration to both sides. Integration will cancel our differentiation here. We have our y times e raised power the integration of p dx is equals to the integration of q of x times e raised power the integration of p dx, and here our dx at the back. So that is that, and yeah, we put our dx both sides here so that the dx will cancel the dx here and all. So since we have this as this, we can make our y subject to the formula. We have our y is equal to 1 over e raised power the integration of p dx times the integration of q of x e raised power the integration of p dx, and we have our dx. So now this is how we got our formula for this, and that this here is how we got our formula for our integrating factor. So now we can realize that these formulas are not just formed out of the air. They are something that are actually that can actually be proven. Their sources can actually be proven. So in our next video, we are going to be solving questions on um, linear equations, and then we can move on.